Welcome everyone, and thank you for joining us today for our webinar on driving high throughput NGS library prep with automated liquid handling. I'm delighted to be joined by Curtis Knox, who is the Director of Product Management at seqWell, where his primary focus is on the development of products for the synthetic biology market. His responsibilities include the release of the ExpressPlex Library Prep Kit, which will be featured today as part of our discussion. I'm also joined by Paul Lomax, Head of Genomics at SPT Labtech. Paul works closely with researchers and collaborators to develop new automated solutions that address challenges for labs working in the life sciences. Notably, Paul led the development of the Firefly liquid handling platform from initial concept design through to its launch last year. Before I hand over, I'll just run through the agenda for today's webinar. Paul and Curtis will first be exploring the challenges facing researchers in synthetic biology discovery, offering their perspectives based on their individual areas of expertise. They'll then speak about the collaboration between seqWell and SPT Labtech, walking through how the partnership started and then taking a deeper dive into both technologies. They'll then highlight the key benefits from the synergy between the ExpressPlex Library Prep Kit and Firefly and the impacts of this on the industry, allowing for better and higher throughput library preparation. After their discussion, we'll then have time for a Q&A, so if you do have any questions for either of our presenters today, please post this in the question panel and we'll answer as many as we have in the time that we have. So without further ado, I'll now hand over to Paul to begin the presentation.
Thanks, Rachel, and welcome everyone, and thanks for joining the call today. This all started about at the start of the year when we first talked to Curtis and seqWell, and back then Curtis had some pretty clear ideas about what was needed for synthetic biologists. Could you actually just kind of share your thoughts from back then, please, Curtis?
Sure. So, as Rachel mentioned earlier, a lot of my focus is on synthetic biology, and really what I wanted to try to tackle with SPT was thinking about how synthetic biologists and researchers do their discovery today. And really what it comes down to is a tremendous amount of what I call rinse and repeat. In other words, you need to make new constructs, sequence those, analyze them, and then turn around again once you've actually looked at what you've created and say, okay, well, now I need to do this, or I didn't have what I really needed. So it tends to be a very repetitive action. And the quicker and easier that you can work through this type of system where you're trying to continuously construct and analyze, the quicker you can get to your discovery. So our idea here is how can we go about and make this process simpler for those that are doing it. And one of the things that we really thought about was, well, okay, so we can work with SPT in order to automate some of these systems. And I'm going to kick it back over to you, Paul, to think a little bit about what systems might be useful and how we went about thinking what might make the most sense.
Yeah, thanks, Curtis. So, yeah, I mean, the really interesting thing about the ExpressPlex protocol is it's beautifully simple. I mean, and it's really great for automation. So, as you can see from the slide here, we've got a number of products that could actually all be used to run the protocol to some extent, and it was a case of trying to decide which was the best platform to do that. And our products range from, on the left-hand side there, we've got the kind of simple semi-automated 96 and 384 well pipetting systems, through to we have non-contact dispensing systems. We also got ultra low volume positive displacement pipetting systems, and then we've got kind of more walk away platforms which have got a higher level of automation. And within these there are a few core technologies that we employ. So the first of those being air displacement pipetting. So there's a video just about to show this. Here we see a 96 head pipetter that's just doing a simple transfer from one 96 well plate to several other 96-well plates, just replicating. We've also got 384 pipetting heads that will do same sort of thing. And we also have positive displacement pipetting technologies. So this next video is just going to show our mosquito system, and here we're actually transferring 100 nanoliter aliquots from a microplate here, just dispensing onto a lid, just so that you can see those droplets. But that's a positive displacement system that works great for miniaturization. And then we've also got dispensing systems. Here, this next video is just going to show our non-contact dispensing. Here, 2 different liquids being dispensed simultaneously, forming a gradient within a 384 well plate. So, you know, we've got all these kind of weapons in our arsenal, but ultimately we settled on using the Firefly, which is our kind of most recent addition to our liquid handling portfolio. And this is kind of all-in-one platform. So this actually combines 2 of those technologies that I just showed you. It combines a 96 and 384 pipetting head, and it also has non-contact dispensing, along with incubation and shaking, and a really kind of simple, intuitive user interface. And kind of the main reason that we chose this platform was, one, that it was great for the whole plate transfers that we needed for the high throughput in this workflow. It can also work with a single column of tips, which lent itself to the pooling part of the protocol that I'll show a little later. But also, I think we acknowledge the fact that this was probably one workflow that synthetic biologists might be working on within what they do. So it lent itself to other applications as well. And the great thing is, with the ExpressPlex being so quick, that actually there would be plenty of time to do other things on the platform as well. So it was a tool that we could supply that could be used for many things, you know, and this workflow being one of them. So maybe that's a good point at which to kind of switch back to you, Curtis, just to explain a little bit more about the specific ExpressPlex workflow.
Sure, and thanks, Paul. So this has been really exciting for us to release this year, and it really was designed for the the synthetic biology world, where there's a lot of amplicons, there's a lot of plasmids. But what I want to do is first kind of walk through what this workflow looks like, and it'll be very obvious why something like this is very automatable as well. But really what you have is a system where you have 2 pipetting steps to begin with to really set up your system. So you start with an indexing plate, which you can see in the upper left there, that has our tagging reagents on them. And I'll describe what that really means in a second. And then you get a reaction mix plate, what we call our ready reaction mix, but this is basically a master mix. And then you supply a plate of your DNA samples. And the process is simply transferring 4 microliters of your indexing reagent into your ready reaction mix, and 4 microliters of your DNA into that same ready reaction mix plate, sealing that and putting that on the thermocycler. After the thermocycling program is done, then you will pool all the samples into a single tube for that plate, and then you will do a single paramagnetic bead cleanup. And really what this comes down to is this is approximately a 90-minute workflow from start to finish, including the cleanup and everything else. There's 30 minutes roughly if you were to do this manually by hands, and that's really, for the most part, in the magnetic bead cleanup at the end. What's really cool and exciting about this system, and what makes it different from anything else, is that you're doing the fragmentation, the barcoding, the amplification, everything all in one step. And unlike some other tagmentation, fragmentation based systems, you don't have to go out and buy your primers. You don't have to buy your separate barcodes. Everything is built into the initial tagging step. So when the tagging happens, you are physically adding every bit of the Illumina compatible adapter from start to finish at the point of tagging and fragmentation. And what that allows is a system where you really don't have really any chance for crosstalk between your samples, because everything's going through this system individually until the point of pooling and cleanup. And as such, we're doing this in 96 well plates now. We're expanding this in the future to 384 and other versions as well. But this allows you, with the setup that we have now, and as we're going to describe, the chance to run through as many as 1536 samples, including the sequencing, in a 24-hour turnaround, which is really exciting for customers. Now, one of the really cool features also of the ExpressPlex kit is the normalization aspect of the system. And what I mean by normalization here is that, we ask our customers, how variable are your samples coming in? And this system is tolerant of really a 10-fold input. We shoot for 4 to 40 nanograms. We like it in 8 to 40 nanograms total input, but we've seen a 10-fold input range works really well. And if you know roughly what your samples are coming out of your extraction or rolling circle amplification, or however else you're getting your DNA from, say, your plasmids, just do a simple global dilution across that plate. And you don't have to go through and individually normalize your samples or anything like that to get it into range. And what we're showing here is a comparison of ExpressPlex versus, say, Nextera XT, which is obviously one of the more common systems that people would use for this. And even when you are individually normalizing those samples there, you see the variability that you can get in your read count levels across those samples. And the more normal your samples are coming out of that is something that allows you to just save time, save sequencing costs, and as you'll see in the next slide in a second, just the ability to actually assemble your plasmids very quickly. So with that in mind, as we start to think about plasmid assembly, what we've found is that, even at fairly low read depths, here we're describing just 500 mean read pairs per plasmid, in that we're able to get 100% error-free circularized plasmid assemblies. And we see this routinely where you're not necessarily getting that at these levels. You have to go up to higher numbers of read depth in order to get those full assemblies. So one of the thoughts here is that, higher success rates, as well as the potential to actually multiplex more samples or multiplex other, non-plasma samples or anything to maximize the use of your flow cell there, such that you're cutting down your sequencing costs overall. And because of this, we're actually expanding this product to 6,144 barcodes around the turn of the year. So you'll be able to do even more samples, throughout this system. So, as you think about, this workflow overall, and as you can see how simple this is, it made a lot of sense to partner with someone like SPT in order to automate this, to enable to turn around and get the flow and the throughput that most of these customers do. And we've actually in-house done the ExpressPlex workflow on the apricot and also in a miniaturized version with the mosquito, but we focused on the Firefly here for the throughput aspects of it. So I'm actually going to kick it back over to Paul here so that he can talk about the how this is set up on the Firefly and what the workflow looks like there.
Yeah, thanks, Curtis. I mean, well, the key word here is simplicity. It really is a really nice, simple workflow to automate. As you can see from this slide, these are just a few screenshots from the software. The key point here is the whole protocol is shown on the top screen. It's a very visual UI, but there's only 9 steps in it. And in terms of what we need to load onto the deck, there's just two tick boxes and 3 plates. Within the UI, there's a really nice loading guide which kind of walks the user through the setup. So even though it's nice and simple, this really could be used by somebody who's never used automation before. They could follow the guide, load it, and go. It's really that straightforward. And I'm actually just going to run through some videos of the protocol in action. So this first one is just going to show that the first part of the protocol. So it's just loading on 96 tips. This is running at double speed, by the way, just to kind of go through this nice and quickly. But the first addition is the indexes into the orange plate, which is the plate that has the rest of the kit essentially in there. And then it's changing tips. So second set of tips coming along, and now it's going to go and aspirate from the samples, the DNA plate, back into that orange reaction plate. And once this transfer is done, there'll be some mixing. So they're just pipetting up and down to ensure we get a good mix of everything, all the components in there. And then at the end of this, that plate is ready to go to the thermocycler. So it really is that simple. That's sped up 2 times. So, you know, you get a real sense of just how quick it is. The second part, so once the plate has been taken off and gone through thermocycling, it's brought back. The deck is replenished just with a box with a single column of tips. So we've got the plate back, and we've now got a new destination plate, and we're just simply pooling. So we're aspirating across the first 6 columns of the orange plate, and we're dispensing to the first column of the white plate that you see, and then it'll go back and continue from columns 7 to 12, again back to the first column. And once we reach that point, the whole protocol is complete. Again, this is running just double time in the video, so you know it's still very, very fast. At that point, the white plate can be removed. A manual pipette can pull those samples to a single well, and the bead cleanup's just done on a single tube. So you know, from our experience, it doesn't get more simple than this. You know, it's a really beautiful kit to automate. And I think at that point, it's good to just have a look at the results, because I think it's fair to say, Curtis, that you're pretty pleased with how it looks.
Yeah, absolutely. And you know, as part of this validation between the two companies, what we did is, you know, we sent over the reagents, and we sent over you know, the DNA samples and everything, and then we had you know, your team run multiple plates through this, and then we compared directly to a manual plate that we prepared in-house. So you guys prepared these in the automation system, sent them back to us. We had manual prepared plates here, then we ran them all together on the sequencer. And, you know, it's just beautiful. You could lay these on top of each other, you know, absolutely no loss of reproducibility. And this is exactly what you want your automation system to do, is to be able to just run this time after time after time in such a way that, you know, you're allowing your techs to do other things, or to be able to feed this system in such a fashion that you can turn around a lot of samples very, very quickly, which we'll talk about, you know, in a few seconds here, without any concern about the, you know, the reproducibility of these samples going forward. And so while I don't show assemblies or anything here, really what we're looking at is reproducibility, and couldn't be more pleased with the, you know, how tight these are comparison across the board.
Yeah,
so,
I think it was great to see such great results, and as I say, it just went so smoothly in terms of automating. I think, you know, one thing that you've touched upon throughout this, and you know, where we started out right at the beginning was the need for high throughput. And I think what we see from this point is that there's the ability to push this a lot further in terms of the throughput. And you mentioned, I think, 384 well plates and greater numbers of indexes. So I think there's plenty of scope to actually push this even further than we have already.
Yeah, and if we think about, you know, going back to our original question here of, you know, what does it look like to be able to start to finish and continue to get through these samples on a regular basis and push the speed of your discovery. So, you know, we've got a nice little kind of visual here for us to think about what it takes now to do, you know, 1536 samples and have that from the point of extracted DNA to the point of actual sequenced data in 24 hours. And so I should note, you know, the videos and everything that we've shown up to this point has been doing one plate at a time. very easy to do this, 2 plates at a time. And so as we've kind of demonstrated this and worked through the timings and everything else, what you can do with this is a situation where you can run 2 plates at a time for the physical setup of, the libraries to put them on the thermocyclers. So, it only takes a few minutes to do each of those plates. In 40 minutes, you can have 8 plates set up, put those on your thermocyclers. While those are thermocycling, you can have another set of 8 plates running in order to generate 16 total plates, which is your 1536 samples. At the point at which that thermocycling is done, pull those plates back, then turn around your second set, put those on the thermocyclers. You can be pooling your original 8, and you can do those 4 plates at a time. As you see, it takes very little to pool those plates. And then at the end of that, you've got 16 individual tubes of libraries that we've typically been doing that library pool or cleanup individually just by hand, because it really doesn't take much to do that. But obviously automation companies are very capable of doing that type of thing as well. So it wouldn't take much to continue to do that in the end. And in 4 hours, you have your 1536 samples set up. At which point then you put it on your sequencer, run it overnight. It's approximately a 19 to 20 hour run on a MySeq for a 2x150 run. And in the morning, you're coming in, and by midday, you've got your data back, at which point you can be, starting the next set. So it's something that, one individual with the Firefly can be running through a lot of samples very quickly to generate that data, so that the companies can be focusing on their discovery and understanding where they want to go, where they want to be. And as I said, we're expanding the barcode set that goes along with this, and thinking about 384 or whatever else, so that as your throughput scales up, we can, between the 2 companies, we can scale with you in order to really help you get through massive amounts of discovery, of which, maybe that seems like overkill for a lot of people, but we're really finding that this is what needs to be done. Whether this is something you do every day, 365 days a year, or if this is, big project pushes where you need to get through a lot of samples very quickly so that you can then sit and analyze your data and decide what your next project is. Either of those will work well with a system like this, such that you're not spending all of your time on the bench. You're spending your time focusing on the discovery and getting to that end result that you want to be. So, with that, Paul, kind of kick it back to you to kind of think about, what our conclusions are, and, and where we want to, hopefully help people get to.
Yeah, thanks, Curtis. I actually think you did a pretty good summary there, actually, in your discussion on that slide. But I think these are probably the 2 main takeaways. We're providing new tools here with this combination for a much faster turnaround of those critical experiments. And I think one of the things you stressed time and time again then actually was that it's about enabling scientists to focus on discovery and actually not just standing at the bench pipetting. It's a big difference between trying to do those if you're trying to do 4 plates a day manually, that suddenly becomes, even with such a simple process and protocol, it's still quite a lot of time stood there pipetting, along with all the things that go along with that, like manual errors and fatigue and so on. Whereas it really is really quick and really simple. And as I said already, there's the scope to push it much further, I think, particularly looking at things like 384 wall plates. So I think that last point, can't be stressed enough. It's really about giving scientists the opportunity to focus on analysis and discovery, and not standing at the bench pipetting. So I think that brings this to a close. And I suppose the last thing to do is just to share some contact details. If you do want to reach out, and you can do so at these addresses, and we'd be happy to speak to you from either side in more detail about this.
Wonderful. Thank you both for that insightful discussion and for taking us on the journey of this collaboration. As I said at the beginning, we do have time now for some questions, and I can see that we've got some coming through already in the chat. So if you have a question for Paul or for Curtis, then please keep posting them and we'll get through as many as we can in the time we have remaining. To kick off discussions then, the first question that I have here is, what advice would you give to a lab considering a large-scale ramp-up of their sequencing?
Yeah, Paul, do you want to take the instrument first?
Yeah, I mean, well, actually, I'm going to kick it back to you because I'm going to say, if you're thinking of kind of scale up, I think the first thing is getting the process right. You know, I think you need to have an application, a protocol that works, that you know, and then I think from our perspective, our applications team are, you know, kind of happy then to look at working with our customers, looking at the workflows, and then looking at which flavor of automation might suit it. But I think the other thing is probably about expectations. I think automation can definitely improve consistency. You don't get kind of user to user variability. It can definitely improve throughput. What it won't do is suddenly give great results with bad samples, and it won't suddenly give you, you know, much better data than if you were getting really poor data for whatever reasons before. It's unlikely to fix that. So I think you start with a protocol that is solid from a kind of chemistry point of view, but and then, you know, you have a good idea of what kind of throughputs you're trying to achieve, where you'd like to get to with it, and that's always a good starting point for us.
Yeah, and I would add to that actually the idea of you know, starting from the other end and saying, you know, what does done look like? Because someone always used to tell me in that, you know, what's your goal? How many samples do you think you need to process at a time? You know, what does your labor look like? What does your bench space look like? And then sit down and talk with people that are knowledgeable, like ourselves, or other people that you know, have done something similar, to learn. And you know, there are really great ready-made solutions, like exactly like we're talking about today, that'll hopefully get you very close, but you might have to tweak a little bit something here or there, and people are here and willing to help you with that. So those are the things to, you know, just to think about what you're really trying to achieve, and then sit down and talk, and you'll find that, you know, knowledgeable people will be able to help you put together the system that really makes sense for you.
Thank you both. Hopefully some good advice then for our audience there. The next question that I have is, Firefly seems like an overkill for this application. Could this not be done on a simpler system?
Yeah, that's a good question too, and I think that comes back to sort of what I answered in the previous one. I think when we work with customers and look at workflows, it's often a discussion around, you know, again, going back to Curtis's point, what is the objective, where you're trying to get to, what's the throughput level, how much hands-on time are you prepared to work with, what are the key bottlenecks. So there are certainly instruments within our portfolio that could be used that are kind of simpler, lower cost systems. They'd require a little bit more hands-on time. But yeah, you know, we do have solutions that would suit smaller budgets. I think we chose Firefly because it could do the whole thing in the most walk-away fashion. And I think, as I mentioned, it's expected that there are other workflows going on in the lab as well. So, you know, it could be used for other things when not being used for this protocol. But yeah, there's certainly hopefully you saw the simplicity of this protocol during the presentation, and it certainly lends itself well to a good 4 or 5 of the solutions that we offer for sure.
Thank you, Paul. The next question I have here, I believe, will be for Curtis. And so, Curtis, can you speak a bit more about the types of applications, other types of applications that people can use ExpressPlex for, whether that's RNA sequencing, DNA sequencing, and which species do you recommend?
Sure.
depending on
So
genome size?
yeah, so in general, the product is a generic input of DNA, get out library type of thing. There are certainly certain applications where this works better for than others. So we have intentionally focused to start on SynBio applications like general, normal size amplicons, starting from about 350 base pairs up, as well as plasmids. And we've tested anything from small plasmids up to about 20 kb right now. Certainly, likely can go further than that. It's just a matter of the number of reads and things that you want. Small microbial genome work is another area that we've started to work into, where we know that something like this would not be valuable would be in highly degraded samples like FFPE samples or circulating cell-free DNA samples. Those just in general are not great samples for TN5 transposase-based library methods, regardless of the manufacturer of that. This is also not a product for high complexity libraries. You're looking at whole genome of larger genomes, things like this. So there are certain areas where a product like this works very well, and certain areas where there are other products, including from seqWell and others, that are more amenable to that. There was one mention of RNA-seq. You can't input RNA into this, but if you do have cDNA that you've created for something, as long as you're getting it into the appropriate concentrations coming in, then we certainly have seen that work and have done some of that ourselves internally. So we'd be happy to talk to anybody that's doing bulk cell RNA, full length transcript work, where they're turning that into full length cDNA, and then that can be input and basically treated as amplicons in that case.
Thank you. Thank you for that detailed answer. The next question I will field out to the both of you, and that is, are there any challenges I should look out for if I want to incorporate automation into my workflow?
Paul, why don't you start?
Yeah, I mean, I think it's an interesting question, actually. Yeah, I mean, I think the first thing again is about expectations and what you want to get out of it. I think also, having clear goals. It may be, as I've already said in previous answers, about what type of throughput you're looking to get to, how many different users there may be, how many different applications that you may want to run on it. And actually, one thing that's quite common often is that people have a whole list of things and then don't think about the scheduling of it actually. So you can often end up with kind of queues and the robot and so on. That's quite a simple one, but I've seen it many times where it can become a real problem. So I think just thinking practically about how it's going to work, allowing time for setup. Do you, there are PCR steps in a lot of the workflows that we work with. Whether you're going to, some labs lock an instrument down while somebody's doing a complete workflow. So, it can be standing there idle at times, but they prefer just to keep it kind of signed out to that user. Other labs will kind of try and use it more efficiently, where somebody else can jump in for an hour perhaps while the plate's off for thermocycling. So there's kind of, I would think, just kind of think practically about the usage of it. I think in terms of the actual setup and running of the application, I think looking at if the vendor's already got methods available or how easy it is to write and adapt new methods. I think our experience is, we have a lot of methods available for a whole range of kits. Customers still usually want to tinker and customize them further to suit their specific needs. So I think making sure that you can do that and you've got people in the lab who are both interested and capable of kind of getting to grips with the software. The software on our products is generally pretty easy to get up to speed with quickly. So yeah, I think it's just being open to maybe some changes that maybe suit automation better than what you may do with manual methods. And I think you know, listening to the advice of field application scientists who work with vendors, work for vendors, to kind of maybe, I guess, being open-minded to be flexible on certain things and certain changes from a manual process in order to make them better for automation.
Yeah, and I would second and add to what Paul said here. And when you think about incorporating automation, especially if this is the first time doing something like that, consider what pieces of your workflow make sense to automate and what may not make sense. The reason that I say that is there are portions of a workflow that you can automate almost any of it, but sometimes you have to look at how long are you tying up that instrument to do a relatively simple step where you could be doing many more of a more complicated step more efficiently on that robot. You know, for an example, not necessarily for Firefly, but you do see platforms where there's a thermocycler on the deck of a system, and you end up tying up the system for an hour or 2 hours when you could have had that off deck and doing other things with it very simply. Much like you saw that, you know, right now we still do the final bead cleanup off deck of the robot, but you could absolutely automate that portion of it. And you just have to decide whether that's the most efficient use of your time and space on that deck compared to other things that people could be doing with that instrument.
Thank you both. Thank you. The next question I have here is for Curtis, and that's can the DNA input for the ExpressPlex workflow go below the recommended 8 nanograms? For example, 1 nanogram. What's the volume required for the DNA input?
Yeah, so we do try to, you know, have that minimum at 8 nanograms is our recommended input. We have absolutely tested down to 4 nanograms, and that works the vast majority of the time. You may occasionally see some dropouts. At 1 nanogram, my guess, we have not tested down that far. You will get some of it to work, but you will have dropouts in there. So it depends on your tolerance for your success rate of some of those situations. But that is something where if that is all the DNA you have, if it's concentrated enough, we can look at potential of, you know, miniaturization so that you're getting an equivalent amount for the size of the, you know, reaction and things like that. So there are some ways for us to help you with that, but we do recommend, you know, as with any product, you know, try to get in the range that we have tested well.
Thank you. And then I've had a few other questions coming in asking about other kits that can be performed on Firefly. So Paul, I'll just open it up to you. I wonder if you can just speak about that a bit more in general.
Yeah, we're the library of kits that's available is building up all the time. And interestingly, so the Firefly architecture has basically got a cloud connectivity element. So there's a community within that, and as we post applications, they're immediately available for customers to download. So we've already got a range of kits from, you know, a number of the main vendors in the market, and that continues to grow. There's also two routes that we do that. So I mean, this example with the seqWell kit was done in our in-house lab. And there we tend to kind of go, you know, for quite a kind of heavy validation, and we run many times and make sure we've got good reliability and repeatability, and we do the QC and ideally go on to sequencing as we have done here. We also do develop methods in the field through our application scientists, and those also get posted to the community, often with a degree of health warning that it's, you know, it's been developed for a specific customer, and it's, you know, it's obviously subject to their sample types and so on. But that does mean, you know, in the Firefly was launched last year, but already we've got a good number of available chemistries already, and it's growing rapidly month by month.
Thank you. Another question that I have here, what's the typical setup time for this application to be loaded onto a new system?
Well, I can speak to that from our point of view. I guess if a customer was adopting this with Firefly, because of the way Firefly is set up, in terms of when it's installed and kind of the calibration, essentially protocols are completely transferable from one system to the next. And as I just mentioned, you could download this from the cloud. So from that point of view, if somebody had a Firefly installed and they received the kit from seqWell, once they've kind of had it installed, done the basic training with our service team and our applications team, which is pretty quick, they could download it and run it. It really is as simple as that. The setup time, well, is essentially zero in that once the machine's been set up and calibrated. If they were coming to a brand new kit, if it was a download and they run the protocol as we've written it, then again they should be able to go as long as they use the same labware and the same approach, then it should work. If they're looking to develop their own method, it really just depends on the complexity of the method, and you know, then you can get into the sort of stuff we do when we're developing methods, the fine tuning of pipetting steps and mixing steps, which, you know, can take some time, you know, and in some cases can take several days of fine tuning depending on what the process is. So it's really quite variable. But if it's something like this where it's a tried tested kit that somebody wants to just download and run, then literally immediately.
Thank you. And then I think we'll make this the last question that we'll answer live. Any that we've not got around to answering, we can of course follow up with email. But then just, I guess, to end things off for today, Curtis, and this one is for you. And it looks like everything you've talked about is a 96-well format. Are there any other formats for the ExpressPlex product?
Yeah, absolutely. You know, we launched the product with 96, and we are actively developing that into a 384 well version of this product, moving from 1536 barcodes, which is what's out there now, to 6144 barcodes. And that's actually, we could put that into people's hands as early access now. Then we'll have that fully launched right around the turn of the year. So for our, what I would consider, you know, very high to ultra high throughput customers, that is something that, you know, both of our sides can help them move to pretty quickly.
Thank you. So I believe then that's a wrap for us today. Thank you again for everyone who's joined us and has stayed with us all this time. Thank you again to Curtis and Paul for their time and for their presentation today. We will follow up with any questions we didn't get around to answering via email, and I hope you all enjoy the rest of your day.
Thank you, everyone.
Thanks all.